Top, it's just an option. All right, let's check this out. Let's see, we have people watching, not yet. All right, let's screen share. Let's wait, hold on. Okay, I'm wondering if they can hear. Yeah, they can hear us. Okay, good. All right, okay, so here's the deal. So they are requiring first hour. You are my first hour to check in during first hour every day or you will be marked absent, okay? So tomorrow you need to set an alarm. You need to go into your first period class and you need to do the attendance question, okay? So starting tomorrow, I'm gonna put an attendance question up there. I'm gonna have a whole module that is just for attendance. If you don't do yours before the end of first hour, you will be marked absent for that day for the rest of the day. Okay, so even though you're going to be working virtual, you absolutely must check in first hour. That is how you get your attendance for the entire day. Now, your second hour teacher, your third hour teacher, they may have a policy for those periods throughout the day, but for our school attendance that says whether you're present or whether you're absent, you must check in first hour. Okay, so make sure you're doing that every single day. I know some of you have just been sleeping in and waking up at 10 and doing your work, okay? If that's what you want to do, you're still going to have to set an alarm, do your attendance question, and then go back to sleep if that's what you really want to do, okay? But the school board, this is coming from the school board, this is not coming from Mr. Badgley, but the school board wants all of their students to be up, awake, first hour, checked in, okay? Whether you're virtual, whether you're hybrid, A day, B day, it doesn't matter. Everyone needs to do their attendance question before the end of first hour. Any questions on that? Any questions for my Zoom people? Anybody Zooming with us? Still not. Okay, now this will still be optional, okay? But if you're up and you're awake, then you might as well Zoom in, okay? Now, on Thursday, you guys will be in class on Thursday. I will be absent. We have a funeral that day. My family has a funeral. So I will not be in class, but we will still be rocking and rolling as if I was just here. On Thursday, you need to bring your device. You need to bring your headphones because I will be doing an ed puzzle for you. Okay, so I'm going to record my video, put it in as an ed puzzle. You will be completing that in class and doing your notes at the same time. Okay, so all of that will be there for you to do in first hour. So it will basically be like it's not a day missed. Okay, so I love that as a teacher. I typically hate to be out because I feel like I'm getting my students behind and I'm not giving you instruction, but that's not the case anymore. Okay, so on Thursday, I won't physically be in class, but your lesson is there for you. You are not going to have just some busy worksheet. You're going to be in your book doing your lesson. Okay, so I think that that is a great thing that's coming from this virtual learning is there's no more just busy work days. So make sure you come to class Thursday prepared with your headphones so that you can watch your ed puzzle. All right, the sub will not put it on the board. You will have to watch it on your device. Got it? Any questions before we rock and roll? All right, let's do it. Okay, so if we go back to our Zoom page, not our Zoom page, I'm sorry, our Canvas page, you go into your modules. Ooh, we're running slow today. I see I have a participant. If you can't hear me, make sure you unmute yourself, Charles, and tell me that you can't hear me. It looks like it's working well, but just make sure you do that. All right, so again, you have to mark the first one done. Okay, so at some point, mark that done. We've watched that. If you haven't yet and you're watching back with this Zoom, absolutely do that first, must watch. All right, so then we're going to go into our lesson for today. 9-8, lesson 1-1. So we are in Springboard until further notice. All right, there's some instructions for you. It does say it's due by midnight. Everyone should be up and running, okay? So unless you have some kind of excuse, you should be up and running. I sent Mr. Badgley an email that I received on Friday that said, I'm sorry, I don't have good Wi-Fi signal today. I'm not sure I'm gonna be able to get your work done. His response to me was, give the student a 0, okay? So it's no longer going to be an excuse whether your Wi-Fi works or doesn't work. Like, you're at school, you may have to go sit in McDonald's parking lot to get good Wi-Fi, but you have got to get your work done on that school day during the time allowed. You can't just say, I don't have Wi-Fi, I don't have internet service, I can't get on the computer. None of those excuses to Mr. Badgley are going to be an excuse. If you can't get it done, you get a 0, okay? So make sure you're doing your work. Make sure you're doing it early and don't wait till 11 o'clock and then realize you can't do it, okay? All right, so if you click on that, it's gonna load in a new page. By loading in a new page, it gives you the entire screen to work with, okay? It doesn't limit you to a smaller box. Oh man, we're running slow. Yeah. Your percentage that's on Delta Math is the percentage that you're gonna get. I have not gone and updated those. So if you've gone back and done more work, I still need to update those. But like if you look at Delta Math and it says that you got 74%, then that's what goes in the gradebook as a 7.4, okay? Okay, this is loading super slow. So is y'all's loading? Yeah, okay, cool. Then I'll just pull up my document from my Algebra 2. What's happening? Oh. Do I have too many things open, you think? That's geometry. What is this? Get rid of that. Get rid of that. Hope I didn't just exit out of the Zoom. No, I didn't. Okay, y'all. Let's try this again. Maybe if I close all those things out, it will allow it to load. All right, here we go. No, that's not what I want. Here we go. Well, this is super. Algebra Unit 1 student book. What's happening? I'm sorry. Hey, stranger. Did they take your temperature already? Perfect. You can throw that in the trash. We're going to have a lesson today if this will ever load. Awesome. What is happening? Is my Zoom still working? Are y'all still with me on Zoom? You never got what? Well, I'm just talking about Charles, who's in there right now. Which he's not responding. I don't even know what's happening.
I think it's still going.
Okay, sweet. Thank you, Charles.
Yeah, sorry. My dogs were barking earlier, and I didn't think that was something you wanted to hear.
That's okay. That's okay. Okay. This is a good sign that this is loading. You have your textbook today? We're on page 3, if we can ever get there. Yes. Praise the Lord. All right, here we go. We can go now. All right, so this, if you've done Springboard before, you know that the learning targets are there for you. Everything is here for you. So if we look at this, it says create an equation in one variable for real world content. Okay, so what we're going to be working on today is one variable equations, like x equals 2. That's one variable equation. But we're going to be doing that in a real world context. Okay, so just up yet. Man, we are just crashing and burning today. I should have got here at like 5 a.m. to like make sure everything was up and running. Hey, what am I hearing? Are you listening to something else? Will you turn that off? Take those headphones out. Thank you. All right, let's just go ahead and read while this is going on. Then we're going to be solving that one variable equation. So it says, a new water park is called the Sapphire Island, is about to have its official grand opening. The staff is putting up signs to provide information to customers before the park opens to begin to the general public. As you read the following scenario, mark the text to identify information and parts of the sentences that will help make meaning from the text. Okay? The Penguin, one of the park's tube rides, has 2 water slides that share a single line of riders. So it's just like any other water park where you've got your tower where there's one slide that goes this way and one slide that goes this way, but everybody is climbing the same set of stairs. Okay, so just like any of those water parks where you're all climbing the same set of stairs, and then you can go 2 ways. One group can go to the left, one group can go to the right. Then it says the table presents information about the number of riders and tubes that can use each slide. So slide number 1, tube slide, tube size is 2 riders, and they release a tube every 0.75 minute. The other slide, slide number 2, has 4 riders, and they release every 1.25 minutes. Okay, so they've got this down pretty much to the 100th of a minute. Then it says, how would you say this name? Jabbar? Is that right? Jabbar places a sign in the waiting line for the Penguin. When the rider reaches a sign, there will be approximately 100 people in front of him or her waiting for either slide. The sign states, from this point, your wait time is approximately blank minutes. Jabbar needs to determine the number of minutes to write on the sign. Work with your partner or with your group for items 1 through 7. Well, because of social distancing, you're not working with anybody but yourself, but we are going to do this together as a whole class. Okay? So it says, number 1, let the variable represent the number of riders taking slide 1. Write an algebraic expression for the number of tubes this many riders will need, assuming each tube is full. Okay, so how many tubes or how many people fit in each tube? 2 people. We're talking about slide number 1. Okay, so 2 people per tube for slide number 1. Okay, so we would have to take the number of riders, which R represents the number of riders, and we would divide that by 2. And that would tell you how many tubes you're going to need. If we have 100 riders that want to go on that slide, how many tubes do we need? 50, because 100 divided by 2 is 50. If we had 50 riders that needed tubes, how many tubes would we need for 50 riders? 25. So you're taking the number of riders and you're dividing it in half. That's what's going on. It then says, next, write an expression for the time in minutes it will take for our riders to go down one slide. What's the time associated with slide number 1? That's right. So that releases a tube every 0.75 minutes. So you've got your riders divided by 2. That's the number of tubes. Okay, so I could say tubes. The number of tubes that are going to be going is this many, and you're going to multiply that by the time. Okay, so let's just kind of give ourselves an example to make that make sense. This is just an example over here to the side. Let's say we have 100 riders, and we want to know how much time it's going to take. Let's check our equation, our expression, and see if it's accurate. So 100 riders divided by 2. How many tubes are we going to need? What's 100 divided by 2? 50. And then to figure out what their wait time is going to be, we would then multiply by 0.75. So what is 50 times 0.75? Anybody got a calculator? 37.5 minutes. So if you're rider number 100, okay, you're in this long line and you are rider number 100, it's going to take you 37.5 minutes before you get to the top of the ladder and are going down your tube, okay? So that's giving us an idea about the time, because remember the sign that we're talking about at the beginning of the lesson, they're posting that sign. If you've been to any like water park or Disney or any of these things, you know, they've got these, you're 5 minutes away, you're 30 minutes away, you're whatever it is. So we're trying to figure out what type of sign we would put up. But remember, this only represents slide number 1. We have 2 slides. So let's keep working through this. Assuming that our riders take slide 1 and there are 100 riders in all, write an expression for the number of riders who will take slide number 2. All right, so now we're talking about slide number 2, the riders that are going to be taking slide number 2. So if R represents slide number 1, what we're going to do is we're going to take the maximum number of riders, which is 100. There's 100 people in the line, remember, because everyone's going up the same stairs, but could be going 2 different ways. How many riders are taking the first slide? We're not sure, but we know that it's represented with R. R takes slide 1. So are we going to add that to 100, or are we going to take that away from 100? We're going to take it away. If 40 riders are going to go to slide number 1, how many are going to be going to slide number 2? 60, because you would subtract. Okay, so you got your 100, that's your total people in line. We'll say 40 is going to slide number 1. That leaves 60 going to slide number 2. Okay? Cool. Everybody okay with this so far? Remember, you're either taking notes on your tablet, your device, or you're taking notes on your Springboard, but either way, this is what you're submitting to me. Okay, if I write it on the board, you need to be submitting that to me as your note. Same thing for you people that are watching the Zoom video. All right, so number 4. Number 4 says, using the expression you wrote in item 3, write an expression for the number of tubes the writers taking slide 2 need, assuming each tube is full. Now, how many people can fit in the tube for slide number 2? 4, okay? Now, for the first one, we just said R divided by 2, but remember, R represents the writers on slide 1. So we're taking the writers on slide 2, which is the remainder of the 100. So 100 minus R, those are the writers that are going to be going on slide number 2. And we're dividing that by the spots on the tube, which you just told me is 4. 100 minus R, that's your writers for slide 2. We're dividing that by 2. Now this goes right back to what we were doing previously. It says, write an expression for the time in minutes needed for the writers to take slide number 2. What's the time for slide number 2? That's right, 1.25 minutes. So this represents the tubes. So we're going to rewrite that. So that's going to tell me how many tubes are going down slide number 2, and they can go down every 1.25 minutes. So you're multiplying because it's happening every single time. It's repetitive, so we're multiplying that. Now, number 6 says, since Jabbar wants to know how long it will take for 100 writers to complete the ride on both slides are in use, the total time for the writers taking slide 1 should equal the total time the writers are taking slide 2. So they should equal each other. We've got an equation that represents slide 1. We have an equation that represents slide 2, and they're telling you those two equations should be set equal to each other. It then says, write an equation that sets your expression from number 2, the time it takes for slide 1, to the expression in 5. So what was expression 2? What was it for item number 2? Somebody look back and tell me what that is. Perfect, thank you, ma'am. And then number 5 is just right above. I can still see that. So that's 100 minus R divided by 4 and 1.25. Now, what makes this an equation while the other ones were expressions? That's right, it's got the equal sign. Because it has an equal sign, it's now an equation where the other ones were expressions. So what we're doing right here is we're taking the time for slide number 1 and we're setting it equal to slide number 2. Okay, the time. Now, number 7, which is right below on your notes, it wants you to actually work that out. You're definitely going to want a calculator for this because we've got these decimals. So if you have a personal calculator, get that out. If you're using your cell phone, you're going to want to get that out. All right, let me see if I can drag this up here. I think I can. Oh my goodness, everything just is so much slower, I guess, because of Zoom. All right. Y'all, what even? I should have just rewrote it. All right, so are you waiting on me? Or did you start the distributive property? So we've got r over 2 times 0.75. When you multiply those together, you're going to have 1, which is our numerator, times this, which would be 0.75r. That would be your numerator, divided by 2. Now, we don't want to leave it like that. We've got decimals already, so we're just going to divide. I'm going to take 0.75, and I'm going to divide that by 2. That gives me, anybody? 0.375 R. And we're going to set that equal to, on this side, you're still going to be doing exactly what we were doing, and you're going to be distributing that. But to make our life just a little bit easier, do you remember when you were younger how you had the option to like put it over 1 and then you could simplify across the diagonals? That's what we're going to do. We're going to talk about 4 and 1.25. So if we take that 1.25 and we divide by 4, that is going to give me 0.3125. Then we eliminate that 4 in the denominator. That's going to make your life a little bit easier. That's not required. You don't have to do it that way. But if you do it that way, you get rid of the 4 on the denominator. That's gone because you simplified it out. And then on the outside, now we have this decimal. So now you simply just distribute. Remember, your distributive property tells you to go to both of these. So I'm taking this and multiplying here, taking this and multiplying there. So when you multiply a decimal by 100, do you know what that does without using your calculator? That's right. You move your decimal to the right. So that's going to be 31.25. Move that decimal. If you didn't know that, you could absolutely use a calculator, no big deal. And then you also are multiplying by negative r, so that would be negative 0.3125 r. Now you're probably thinking to yourself, why did they make this so hard? I don't know. I did not write Springboard's book, but this is what we're talking about. We're talking about the time it takes. So this is a realistic thing that somebody at those water parks has had to think about. So now I'm going to add this to the other side. And why did I choose to add that to the other side? That's right, it's got the same variable. So we're going to say plus 0.3125R. You got an ugly decimal over there already. We're just adding another one to it. So 0.375 plus 0.3125. That gives me 0.6875R. I bring down 31.25. Now what am I going to do? How do I get R by itself? Okay, divide. So even though this is not very pretty, we've got lots of decimals, you're still using your Algebra 1 skills that you have learned to isolate a variable. Our goal is to isolate a variable. So I take that 31.25 and I divide by the decimal 6875. Did anybody beat me to that? Do you know what R is? Very good, 45.45, and it is repeating. But remember, we're talking about people because R stands for riders. And so I'm going to make that approximately 45.45 riders. Okay. Now, what we did is we just solved a one variable equation. Okay. Most of you can do that in your sleep. using normal numbers, okay? If I gave you something that looked like this, would you be able to solve that? Yeah, you have one variable. Everywhere you see, you have an x, okay? That is a one variable equation. You've done that in Algebra 1. You can definitely do this. Springboard just made it super extra dealing with all of those decimals. But that's why in Algebra 2, you're going to want to have a calculator. Whether you use your handheld calculator or your cell phone, you're definitely going to want to have a calculator. Okay, so let's make sense of everything that we just did. So let's look at the next page. It says, consider the meaning of the solution. Explain why you should or should not round the value of r to the nearest whole number. Now, what does r represent? The number of riders. We have r is approximately 45.45. So should we leave it like that or should we round? What do you think? Why should we round? Right, we're talking about the number of riders. Is it possible for us to have 0.45 of a person? No, okay? So we must round because 0.45 of a person doesn't exist. Now, you will see this on the ACT. On the ACT, you'll be working your problem out and you'll be dealing with cars. And your answer will say 45.45. And then you have to make a decision on how many cars you're going to be dealing with. So, do we round up or do we round down? Up. Okay? If you round down, you're totally excluding this extra person. What you're saying is, sorry, you don't get to go on the slide because you're not a whole person, okay? So, or you're not a whole car or whatever it is. So if you're dealing with an actual thing, person, car, candy bar, chicken, cats, whatever it is, you are going to round up because it's realistic. Even though I know you have been taught your whole life, if it's below 5, you round down. If it's above 5 or above, you round up, which is correct and true when we're dealing with numbers. But in this case, R represents people. So to include all of the people, we are going to say that R equals 46. And that's the number of riders that are taking slide 1. So you got a line of 100 people. 46 of those people are going to be taking slide 1. So how many people are going to be taking slide number 2? How many? 54. Okay, so let's look at the next question. Use the expression you wrote in item 2 to determine how long it will take to evaluate, how long it will take the number of riders in item 8B to go through slide 1. Remember when we were talking about slide 1 and the time it takes? How long did it take for slide 1 to go down the slide? That's right. And how many riders were in each tube? 2. So this was our equation. So how would we find the time it's going to take for 46 to go down the slide? Plug it in, right? If you get a math problem that says evaluate, what you're most likely going to do is take your information and substitute it in. So instead of R, what am I putting? Good, 46 divided by 2 times 0.75. What's 46 divided by 2? 23. 23 times 0.75 is what? 17.25. And remember, just to make ourselves make sense of something, we're talking about minutes. So it's going to take 17.25 minutes for those 46 people to get down slide 1. B below, okay, which I can't see, but you should be able to see on your notes. I'm going to read to you. B says, how many minutes will it take for the riders to go through slide 1? Round to the nearest minutes. Now, if it says round to the nearest minutes, we're going back to our number rule. Does 17.25 round up to 18 minutes, or does 17.25 round down to 17 minutes?
We've made some corrections to our bell schedule, so the next bell that you hear at 9:24 is for announcements. Students are not to leave the room. That's just the announcement bell. Thank you.
Round up or round down? Down. Because this is not talking about a person or a dog or a car. It's just talking about a time. It's going to take them approximately 17 minutes to get through that, okay? Because that 2 is less than 5, so you round down. Do you see the difference in rounding? Okay, if we're talking about an object, you need to round up. If we're just talking about a number or a value or a time, then obviously you round down. If it was going to take me, 30.25 minutes to get to my mom's house, I would say, Mom, I'll be there in 30 minutes. Okay, so I would just round down to the nearest 30 minutes because that's what it's closest to. Now, if it was going to take me 34.5 minutes, then I would say, I'll be there in 35 minutes, Mom. Okay, I would then round up. All right. All right, so number 10 starts talking about the rest of our riders that we haven't talked about. The rest of the 100 riders will go through slide 2 in about the same amount of time. So your answer to item 9B gives the estimate of the number of minutes it will take all 100 riders to go down the slide. Now, how can they say it's going to take about the same amount of time? Do you remember that what we did is we took slide 1? That's right, and we set it equal to each other. So since this is about 17 minutes, then this should also be about 17 minutes, okay? Because we set them equal to each other, so they should be about the same. So it says from this point, if they put up that sign, you're approximately waiting how long? 17 minutes. If you're standing at this spot, it's going to take you 17 minutes to go down either slide because half of the people are going this way, half of the people are going that way. So it's going to be about 17 minutes. Okay? Y'all are doing great. Let's look at this next one. Number 11. Describe how you could check that your answer to item 10 is reasonable. How could you check that it's reasonable? That's right. Plug it into the equation. And they're wanting you to realize that's what you would do for everything. Okay, if I gave you this equation and you solve that problem out and you have x equals a number, how would you determine if that's reasonable? Plug it back in and do a check. Okay, so you still have that option. You can always do that when you're dealing with equations. Take your solution, plug it back in, and see if you get a reasonable answer. Okay, all right, here we are. Check our understanding. It says, suppose that Jabbar needs to place a second sign in the waiting line for the penguin slides. When the rider reaches this sign, there will be approximately 200 people in front of him or her. What should Jabbar write to complete the statement on the sign? Explain how you determined your answer. Let's look at this equation that we had. Let's see if I can remember it. Help me. It was r divided by 2 times 0.75, right, on that side, equals, what was this? 4 times 1.25. What would be the one thing that we would have to change to answer this question? What is it? The number of people. What's the number of people right here? 100. So we're changing that 100 to what? 250. Everything else would be exactly the same. The way you solved it is the same. The way that we get our answer is the same. The only difference is now we're not dealing with 100 people. We're dealing with 250 people. Number 13 says, explain the relationship among the terms variable, expression, and equation. What's a variable? A what? A placeholder, okay. It's a letter or a symbol that represents an unknown, okay. We don't know how many writers, so we represent it with a R, okay. We don't know the value, so we represent it with a X or a K or a J or whatever it is. It just represents our unknown. What's an expression? What does it not have? It does not have an equal sign, and it represents our situation, okay? So whatever's going on situational, you know, you're moving at 75 miles per hour for an unknown amount of hours. So that could represent your situation, okay? So it represents a situation. An equation is what? It has the equal sign, and it gives you a possibility for finding a solution. An expression does not have a solution. An equation has a solution. I'm sorry, I need to put my phone on silent. All right, so that is a very deep lesson dealing with a very shallow topic. Our topic is one variable equations. This is a one variable equation. Very, very, very simple, okay? But they take it into depth dealing with a realistic situation. OMG, I'm so popular. I mean, like, it's probably a group text. Okay, so this is your homework right here. Like I said in my little YouTube video, there is not enough room for you to do this equation. There's just not. Now, you are going to give this your best bet. I do have a flag. Check it out. Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I'm going to help you guys write these original equations if you want to stay with me. So the pool is currently holding this many gallons, and it fills at this rate, okay? We are going to look at that, and we're going to determine the amount of time with an equation, okay? So this is gallons per minute.
Congratulations to Time All City 2019-2020 soccer team Gianna Horvath, Emerson Roberts, and Neil Letterman. LHSSGA All-State Team Neil Letterman. United Soccer Coaches Association All-Region Team Neil Letterman, and United States Soccer Coaches Association All-Academic Team Brandley Jackson.
If we're filling it, are we adding water to it or taking water away? We're adding it. And at what rate are we adding it? 130 gallons per minute, but our question asks for hours. Where's that? Hours. So what we need to do is say, okay, if it's going to do that in seconds, that at least gets you started. Okay, just know that you're dealing with hours, not minutes. So do your best on those problems. At least try them, submit your work, and then we'll go over that tomorrow. Okay, 14 through 18 is your homework. Yes, ma'am. You watch that video that I posted, but just use your cell phone and then save your picture to your Google Drive. If you don't have Google Drive on your cell phone, there's a free app in the App Store. You can go to the App Store, download Google Drive, take your picture with your cell phone, and then save it to Google Drive. Hold on, I'm on Zoom, so let me, if you're gonna ask me something that you don't want everyone to know, let me end this. Okay. Oh, compliment me? Oh, well, thank you. I feel like a total loser. Today